We left off right here, and I wanted to just reiterate that if your relationship is linear, that means that you're going to have a constant rate of change. Constant meaning it's the same number every time. In other words, if your rate is constant, then you're going to have a linear relationship. That's what you're seeing with this problem. It goes up and over by the same amount every time. It's this steady rate. That means that it's a line. Now, what happens to us most of the time is things aren't exactly a line, but they'll be close to that, close to a line, close to that steady rate. All right, let's do another problem right here with, let's see, a number of large birds that collided with aircraft was 550 birds in 2007, and it has increased by about 21.8 birds per year. Let f of t be the number of large birds that collided with aircraft in the year that is t years since 2000. Find an equation of f. Okay, so what are we talking about here? This is actually kind of a big problem at some airports. Well, you can imagine the wide open spaces, the large amounts of land that aren't being used would attract a lot of things like Canada geese, large birds, that kind of thing. But birds, if they get into the engine during takeoff, or well, actually just in general, if they get into the engine, that can spell big trouble. That was, I don't know if you remember the plane that went down in the Hudson River in New York. There was, it was found that it was a flight of Canada geese that got in the engines and gutted them. So not pleasant for the birds and not pleasant for the people that had to crash into the river and swim out to survive. Okay, so we're supposed to find an equation for f. Now notice this is a steady increase. Let's make a note, right? It's a steady increase, right? They say of 21.8 birds per year. They didn't really say the word steady, but it was kind of implied there. Okay, so that's fine. Steady increase, beautiful. Hold on, I need to change my pagination here just a little bit. All right. Now, how is that going to help us? Well, that birds per year, see that? That's a rate, right? Oh, I keep doing that. I'm sorry. I know what I'm doing now. I'm pressing the wrong buttons. All right, so there we go. It's 21.8 over 1 birds per year, right? In other words, they're giving you slope, right? A rate like that is a slope. All right, so there's your rate, the rate of your steady increase, which means it's your slope. So now you know that it's, and we don't use y, remember we're going to use f of t equals mt plus b. Okay, now what am I getting at? This is the y, f of t part, there's your y, equals m, your slope, t, because we don't have x in this case, we have t, plus b. They said we have t right there, f of t. So we're going to have to use t as our x variable. So it's y equals mx plus b. It's just a fancier way to write it. This is your y equals m. There's your x, your independent variable, which in this case is the letter t, plus b. Now we already know that the slope is 21.8 because they gave it to us. Plus, and then all we need to do is figure out what our starter year is. Well, let's see. Did they give it to us somewhere in here? Yep, right there. See that? That's your starter year. So a couple things to note. You have a rate of steady increase. That's your M. Your starter year is 2007. Okay. Okay, so that's going to be good for us. So we know, let me put it this way. Starter year is 2007. That means that you have 2 points that are given to you. You were given the point 0, 550, right? Because at the time of 0, right there, you've got 550 birds, and that's your starter year, so that's 0. And then increase 21 per year, that's your slope. So let me give it to you in blue. Okay, so that second part's giving you this, right, your slope. And that first part is giving you this part, right, which is your y-intercept. And between the two of them, you've got what you need because it must be plus 550. Remember that the y-intercept, that b value, is what happens when x is 0. So remember, so b is equal to 550, right? Because your y-intercept is what happens when x, or in this case t, is 0. So there's your answer. 21.8 t plus 550. That's your equation. All right, let's do a little bit of unit analysis on that. This is not my favorite thing to do in this particular problem, but we just want to make sure that we perform a unit analysis of the model's equation, this guy right here, in order to determine the units of the expressions on both sides. The simplified units should be the same. Okay, so let's think. The unit for the 21.8. Okay. Well, first of all, what's the unit for the y? Let's start with that. So the y value is going to be the number of large birds, right? Let f of t be the number of large birds. So this y unit is birds. Oopsie. Birds equals. Okay, now the unit on the 21.8, this particular one's unit right there, that was birds per year. We wrote it right there, birds per year. 21.8 birds per year. So that's birds per year. Now time is measured in years. Oops. So that's times year plus that 550 was a number of birds. It was 550 birds. So you say plus birds. All right. Now what's going to happen here? With the year here and the year here, if you have year over year, those units cancel, right? So you're left with, on the right-hand side, birds plus birds. So if I have, I don't know, 550 birds plus 20 more birds, that makes 570 birds. So yes, the units work out. Right? That's your unit analysis. You're checking that the units on both sides, are, oopsie, birds. There you go. That's what you were checking. If it didn't work out, then you know that you'd done something wrong or you didn't have the correct units or whatever. All right, there we go with the unit analysis. All right, predict in which year 700 large birds will collide with aircraft. All right, so I'm giving you the number 700 right there. Now the question is that 700 going to be put in for t or for f of t? So you have to ask yourself, hey, is 700 a time in years or is it birds? And hopefully you see that's birds. So you're going to take your equation and instead of y, you're going to put in 700. T plus 550, and then you're going to solve this for t. So you want to get t by itself. So the first thing you're going to do is subtract 550. And of course, if you do it to the left, do it to the right, keep things fair and balanced. So you're going to have 150 equals 21.8 t. Then you divide both sides by 21.8 because that's no good to you with that in there in the 21.8 t. You just want t, right? You don't want 21.8. There you go. Now these are going to disappear because 21.8 over 21.8 makes it go away. And you're left with t is approximately 6 point something. Here, let me double check. So I take 150 divided by 21.8. 6.88. It's approximate, so I'll give a little squiggly equals. All right. That's not really which year, though. So I guess I should say, and the year for that, okay, our starter year was 2007. So you add, if we round this up to 7, so by the year 2014, for sure, right? And again, the rounding thing, the author's a little bit unclear sometimes whether he wants you to round it or not. I tend, but the rounding one's the one that happens more often, where you round 6.88 up to 7, because if you didn't round it, you'd say in the middle, well, actually towards the end of 2013 is when it happens. So end of 2013, but definitely by 2014. If you round up to the nearest year, or round appropriately to the nearest year, then you're good. Okay. All right, we're done with section 2.4, which means we are done with chapter 2. I'll see you back here for more lectures.